And good morning from sunny Walla Walla, Washington. When the sun comes up anyway, it's 5 after 6 and just getting going in here. It's kind of late. Well, I'm going to do the ultimate test here in a little bit. I'm going to run the Axelson lathe and see if I can be heard. I've got the microphone attached here, and I'm trying to solve a problem with this camera. Everything I see in the camera doesn't necessarily show up in the video. It has to do with the, I don't know what it has to do with. I'll try to figure it out. But I'll try to keep things more centered. So hey, this place, I really like these grates. It works out great for me. In a small spot like this, the lathe and the mill especially throw off a lot of chips. And so without the grates, it's like very fatiguing to walk on those chips all the time. And you have to constantly sweep them up. With the grates, the chips fall through and it's just easier on my feet. That's my feet I'm worried about. So, okay, I got, the nice thing about this size lathe, 14-inch, actual 16, and what does it say, 16 and 3/4 actual swing. And I use 8-inch chucks quite a bit. Those two down there, I could put 12-inch chucks on there. And I got this Bowstar, which was a good buy. It runs true collar chuck to work this drill rod. Now, I don't expect anyone to do what I'm doing. I'm hooking up a tray type situation. I believe that's what those were called, to hold the end measuring rods and micrometer. I'll get a micrometer in there. Now these are 25/64 diameter rods, and I'm using them just because I don't have a need for 25/64 rod as much as I do 3/8. So I'll go ahead and use this for this. And I checked them. I've got I don't know, half a dozen of these, and I've been checking them, and these two are the straightest. It's like this doesn't have to be the most accurate thing, but it should be straight, and I think this will be fine. I checked the roundness of the rod. And this is kind of a handy thing. I don't know how many of you use this. This is a V-anvil micrometer. I'm going to do some work with the jig bore, and this is kind of a tool that's nice to have around jig boring work, because you can make really round holes with a jig bore. You just want to make sure what you're going to put in that hole is round too. So that's comes in very handy, quick check. Otherwise, do it on a V-block on the surface plate. So here's the set of end measuring rods, and I'm making the holders for this. I'm going to make some aluminum ends, and they attach to the milling machine right here. Then there'll be a part that's fixed that, and using a 10th indicator, there was one here handy. But anyway, an indicator will be in here. And if you want to move, let's say this here is 3 inches and some change, you set the change on the micrometer here, and set your stops and stuff, and move it, remove these things, and then move it to 0. One way. But anyway, you can position this table plus or minus 1/10,000. Oh, and I made an error what I stated. I'm getting old. I cannot hold plus or minus 10 thousandths of an inch bore in a hole on this 80-year-old milling machine. What I found is I can do plus or minus 1/2 thousandths. Okay, plus or minus a half on this whole thing with its heavy Tenkin bearings and everything. I believe I have it adjusted really well. And I mentioned before that these 80-year-old machines, they started using precision roller and ball bearings back in those years, but they were new, and spindle designs more or less improved in the last 80 years. So these older machines, you got to warm them up, or they're not going to perform like you want to. I found if the machine's cold, this here, it has quite a bit of spindle play. It's got two, this part's suspended by two Timken Type 0 bearings. And the horizontal spindles, like the accident lathe, has 4 Timken bearings, 2 at each end. Heavy, heavy, heavy duty. I haven't really tested out that horizontal spindle that much, but it's doing real good, and it doesn't need any adjustment. And that's part of the problem too, is getting these older machines adjusted. You just have to take the time. And so far, I haven't I can hold plus or minus 10 thousandths of an inch, and you better be able to do it having one of these things, you know. Using all the tricks and everything, I can hold plus or minus 1/10,000th of an inch on most alloys. I never cut mild steel in this machine. It's always an alloy or a good carbon steel. And why would you use this for mild steel? This workhorse you use for mild steels and larger parts that a little over that Monarch's ability. Okay, I'm going to set the camera over here and try another angle at it all. Okay, I think if I make this thing the machine has 29 inches of travel, which is very generous on the top here. And I think if I make this holder a total 30 inches length, and I think that'd be perfectly fine, and it would actually look right on the machine, I think. Okay. Now this machine's pretty loud. I'm running at 351 RPM. I'm going to part off this drill rod here. Yeah, put a little bit of wax lube on there. This is oil hardening drill rod. And I got that just right about central where it should be. This stuff's pretty tenacious, so I'm going slow. Very good. I'm going to take in, bevel the edge just a little bit. want the camera to fall off there. Yeah, broke that edge real nice. I'll take a file. Okay, that's great. Okay, in the deep corner of my basement workshop, I have this 12 by 18 inch surface plate, and I'm going to lay out what I need to do with the holder or tray to use the end measuring rods and micrometers. Now I'm going to make this tray so it can be used on other machines. And that's how you make these things usable, is have a way to hold them. So once the tray is made, it could be set like on a planer table or something like that that doesn't have the long adjustments. Okay, so I checked out these. I want the rods. These are the ends that I cut off, but I was just checking them for size, roundness, and diameter. I decided on a size of the hole. Okay. Light's kind of weird down here. I hope you can see everything. So let me get this out of the way and I'll set this up and we can see how it's going to be. Okay. Get this one back. I think that's right in the middle and you can see stuff. And this is, I'm going to space them 1/4 inch apart. And this is a brand new 1/4 inch high-speed steel bit that is within 1/2 thousandths of 1/4 inch, and that's good enough. So I want those spaced that far apart, so I'm going to hold them like this on this 1, 2, 3 block. And it's kind of good to do stuff like this up on a block so you're not putting, undue wear on the plate. So I'm going to put it to slip a clamp in there. Okay, that might be too deep. I can use those holes to my advantage. And we can see how this is going to be. There. Push them down. There we go. That was a little off. Yeah, see those clamps are just down in those holes. Okay, so what I got to determine is I got to find center to center. So I'll measure, I'm going to use all vernier calipers too, because they're traditional, right? And this is within the range, plus or minus 1/1000 cents should be just fine, except for the bores that I'm going to press these in the ends. I want them to be specific and use the jig bore. So from this measurement, I can, subtract 1 diameter and get center to center. And I'm going to decide on the height. But let's have a look at another dimension. I want to find this a little more abstract, but really pretty easy to find. And that is the rods themselves. Let's see if I should maybe go a little bit lower. It might be as low as this will go right now. No, it'll go slightly lower. Hope you're all doing good. It didn't want to go, but it went. Oh, here's a piece of mesquite that Ron in Texas sent. And that's an interesting piece of wood. And I haven't worked mesquite, but I look at it as just about any other material, like steel. Okay, oh, behind that is, it's got a long name, I have it written down somewhere, but it's called fish scale. And it's very toxic, so if you're milling it, you have to control the dust. Oh, pretty things are toxic, aren't they? Okay, so here's the measuring rods here. Let me set a micrometer. See the micrometer set in there too. So I gotta find the center distance, and I'll just do it with this height gauge here. Just by eye be fine enough. And bring that around. Let me move that stuff. Okay, it's a vernier height gauge here. It's got a quick adjust with this, pinch this together, and you can lift that up a bit. And then I can bring that on over and down. And find center where that's going to be. And this reads, this is a 1, 2, 3 block here, and it's an accurate one. So the vernier gauge is reading 1 inch. So the center of this, that's the height from the bottom of the rods here. So I'll note that down and then decide how, let's see if I can find that. Okay, this is what the bracket's going to look like right here. And the dial indicator goes up here, right here, and here's the 2 rods. And I'm going to have it just a line-to-line fit of those rods pressed into 2 aluminum end brackets here, and they're both going to be the same. Where's that dial indicator? So I'm going to use AGD dial indicators, and I think this is like a group 0. Might be okay. I like it because it's low profile. I have it in a tail here to use on a height gauge. So how this works, let me pull that around. Pull it from the end like that. I'll slide that back a little. So you have an indicator that these will go up against, see? And work the indicator. Then you have the rods and the micrometer adjustment one. And what you can do, so I'll make it so I can set it on surfaces and use it on various machines. I'm going to make a bracket to specifically attach it to the Brown & Sharpe X-axis, which has a real coarse feed. So that's the name of the game there, how that's going to work. Let's rotate it this way. Usually you have the indicator laying flat like this, see? And that's a 3/8 stem, and you can see I have enough room. It's kind of tight, but it's kind of nice to have this kind of a slim deal like this. And there's advantage to using 2 rods instead of a V channel is because you can bring a pin up from the bottom, and that'll work good on the Brown & Sharpe mill. The last one I made like this had aluminum caps on the ends, but I used a extruded aluminum V channel, which was pretty straight and it worked fine. Okay, that went with the machine. Okay. So we'll get with the program and get that laid out. It's a very simple layout, and we'll get out there and do it on the jig bore. I want to try it, some jig boring there.